Thanks for joining our session. So let's get started now. When I talk to customers, a common target is to optimize their solution running on AWS for their end customers and increase quality. And equally important is to increase their speed of innovation and being faster time to market, so meaning to deliver new features more frequently. And at the same time, also managing their total cost of ownership, meaning to also reduce the AWS spend. And at the end, they're optimizing to get the most value out of every euro they spend on AWS. And today, we would like to show BMW's approach and how the BMW Software Factory is achieving this. My name is Christian. I am a principal solution architect with AWS, working dedicated with BMW. And I have the pleasure to co-present this session today with Thomas, who is a product owner on the Software Factory's software development platform with a focus on their CI offering. It's probably not necessary to introduce BMW, but let me just say two sentences. So with their four brands, BMW, Mini, Rolls-Royce, and BMW Motorrad, it's a world-leading manufacturer for cars and motorcycles. And BMW manufactures about 2.5 million vehicles in 32 factories in 15 countries. But today, we would like to talk a digital factory, the software factory.
Yes, so hello also from my side. I am from this software factory from BMW. Pleasure to be here. Wonderful weather here on the summit. Really great. I want to take you now directly into our topic today with this metric from our CI/CD system. This metric shows how many active build nodes we have. Build nodes means these are CI jobs that are typically building software, can be small software components, can be really huge Linux distribution system that takes a really big machine to build reasonably. And one thing you see here is that there is quite some dynamic. I mean, the system never sleeps. Here's also colleagues over the world working on it, and we have nightly releases and everything and tests. But you see there's, of course, some dynamic in the day. But the other thing you see here is the sheer amount of build nodes that we actually have in use. So this peaks at that day at 4,500 builds. And that means really active builds. And if you think about, if you would put this in hardware and line it up, I mean, that is quite huge. And this is serving our development and serving our integration. And by the way, the colors indicate that there are different types here of builds, but we will come to that. Now, Christian maybe will show you what we did to leverage here AWS and what we did to optimize that at that scale, because it costs a lot and we need to optimize that. But let me also first explain why at all we need that amount of build nodes and build infrastructure. And here's a main reason, or the main reason, because if you look back at the history of the software in the car, I mean, there was a time where there was no software at all in the car. And then it started very specifically like for engine control. And then what used to be a radio turned into an infotainment system. Then there was passive safety and active safety coming in. So there was more and more software coming into the car, but still very focused on the functions and the areas. What we see the recent years is that this software or the functions of the software actually are more and more connected. So if you think about now a car that drives itself and advanced driving assistant systems, you need a lot of sensors, you need awareness where the car is, what is around it, and so on. So the complexity of this increased a lot because of all these connected functions. And this complexity won't go away, so this is inherent to what we have now.
And one important thing to add maybe here, a vehicle is today the most complex customer product. So you have to imagine a modern vehicle like the BMW 7 Series, you can, by the way, experience outside in front of the automotive garage, contains more than 500 million lines of code. So 500. And this is about 30 times the amount of code as a Boeing 787 Dreamliner. So yeah, just have to imagine this.
Now, what can we do to master this complexity and this amount? We talk about 3 pillars in the software development for cars. We have the software in the car, the onboard software. And important there is that we have platforms so that we can build on top of existing functionality. Second pillar is the offboard functions that are becoming more and more important to supply data or to supply updates to the car. Colleague talked also here about this area. And the third, which is normally not so much talked about, is the development tooling for that, and especially for the onboard platform, because that's more specific. And this is what we focus today, and where we saw this chart of the build nodes. Now, what we have been building up the recent years is this is the kind of the heart of our software factory. Actually, it's bigger. There are more things like architecture and so on. But this is what we need for the software development. And you can see there are quite some tools that we supply and connect together. Obviously, source code management like GitHub, but also binary management, caching for the build nodes, and these kind of things. And we need ourselves also tools so we can actually manage this platform, because it's important that this runs 24/7, as smooth as possible. We do this a lot on Kubernetes, EKS in AWS case, and we used to have a lot on-premise, on OpenStack clouds already, but we migrated now more and more to AWS. That is why we are also here today.
Yeah, and to maximize the value for BMW and its customers, so we aligned with BMW on 3 focus areas where we would like spend most of the time, and just taking security as a prerequisite. And the first area is quality. So we aim for an availability of 99.99% of this platform, and the reason is thousands of developers depends on it. So if this platform wouldn't be available or impaired for some time, it's really more than 10,000 developers we potentially impact here. And the second important topic for quality is that we make sure that all these software builds are repeatable. So really making sure that we get the same result out of a build if you have the same inputs here. Second is speed. So we would like to, or we are aiming for reducing the latency developer is experiencing by using these tools on this platform. So whether it's GitHub, whether it's Artifactory, and so on, trying to really minimize the latency. But also for their delay or for the duration they experience when they commit a change to Git, until they receive the build result. So this is also a critical duration we want to limit and speed up every CI build, so to make a developer more productive. And of course, last but not least, it's also cost. So we take a holistic view about BMW's cost of ownership to also reduce this cost. And we are doing this by looking at the specific cost for the platform. So what is the cost of this platform when running no build? So of course, this is something we would like to reduce to a minimum, but then also looking in all of these 140,000 builds BMW is running on a daily basis, and really figure out how we can optimize this even further.
Yep. What I want to explain you now is how actually the software development and integration works in our case. And here we have software developer Lisa, and she has done a change locally in her environment. And actually already at that stage, she needs something from the development platform or from her project, because she needs a baseline that is working. Otherwise, she is actually not able to build the whole stack or validate her function if she needs to validate that on top of the stack. So this is something we need to supply to her, and that's important. And the other thing is that now her journey kind of starts, how she gets this change integrated into the whole, what we call an electronic control unit, so the computers in the car, like an infotainment system. There we want to automate this process as much as possible. So there we have the CI pipelines that start once she pushes this change, like creates a pull request on GitHub or a Gary change, and then the process should be as much automated as possible, of course, except the reviews and all that is needed, so that someone also checks the code. Important there, as Christian mentioned, in the fast feedback, so that we get her the feedback fast, but also that we avoid that she introduces actually a problem. So she wants to prevent herself, but also prevents that something breaks the baseline that we just saw that is actually important also to the others. Because now we have kind of left the developer view, and if we look at a full electronic control unit in the car, there are layers of software like base layer, middleware, application layer, and there are a lot of components sometimes, depending on the size of the system, like an infotainment system. And that means there are developers working in parallel, and they all need fast feedback. They all need a green baseline so that they can build on top. And we need, for all these changes, we need to prevent that something actually breaks the baseline. So the CI system is here very active. And when we do even more tests, like in the release stages, we need to also check the software, maybe then on hardware, if you cannot do that at scale earlier. And of course, simulation tests and so on. Now, that has still been only one electronic control unit. If you look at the full car, and we have different models, different generations, then we as a development platform, which we call CodeCraft internally, so we need to supply this service to all these developers in parallel, because they work in parallel on these electronic control units for the different variants. And this is another reason why we need that amount of resources to support it. How does that specifically work for the continuous integration? There we use a tool called Zool CI. You find there a QR code if you're interested.
By the way, who knows Zool CI? Just could you raise your hand?
Okay, there are some.
Not many.
Because maybe it's not so widespread yet, but we actually like that very much. We use it for many years and contribute to that. It's an open source software. And we have contributed features that are, we think, important for automotive, for example, or for big projects, where you have a lot of dependencies between components, and you need to update them in sync. So that is what we use, and I give you two reasons here. There's some more, but I give you two reasons why we use that. One thing is it can really support complex projects, so that you can create some common CI configurations for a whole area, and then you can specialize that CI configuration for like build variants. So that is very useful. And another reason is, I mentioned this gating is very important. But now imagine you have a complex system, and the software build takes maybe an hour or so to build that. And you want also to have good validation tests and maybe a hardware test at this stage, which also take 1 hour. So you have a 2-hour validation time to make sure everything works. Then that would mean you can only integrate 12 changes per day. And that's by far too little. And what that system does very intelligently is that it actually puts changes on top and starts them already in parallel, but still makes sure that every change itself is validated on the last valid stage of the master of the head of the branch. So that is why we use that system. But it also places a lot of requirements on the infrastructure.
Yeah. So now that we know at a high level how software is built and integrated on the software factory and specifically on the software development platform, can you maybe, before we go into the details, talk a little bit about why there was a need to change the status quo back in the days when you were running on-premises, and why AWS, of course?
Of course. Of course. We have seen this, or you have seen this magic with 4,500 build nodes. The chart here on the left actually shows the development the recent years. So we have been starting small when we started up this platform with just few projects, but then because it was useful and when we had success with this platform, we actually onboarded more and more projects. So the amount was increasing, and also the CI jobs per day, we see that, and actually the amount of CPU cores we need to run all that, which is became quite huge, and that was the main reason that the scale we found we cannot do just with our on-prem resources anymore.
Yeah, so we have seen this graph before, but this time we would like to focus on these colored lines, which shows the different EC2 instance types BMW is running, and this also shows how important variety, but also the scalability requirements are. So since beginning of this year, BMW launched 230 different types of EC2. And the reason for this is, or for EC2 instances, instance types, to be correct here. And the reason for this is there's a quite a variety on software builds the software development platform is executing. So ranging from small linting jobs, which can run on a 2 virtual CPU machine, up to complex infotainment builds, as Thomas mentioned, which probably run on a 128 virtual CPU machine. And what is also quite important here to see is the dynamic over the day. So as you can see, during peak times, the demand is 4 times higher compared during the night. And this was also one of the reasons Thomas mentioned before, a challenge when running on premises, not only from a technical point of view, but also commercially, because all these resources were idling for quite some time.
Yeah. And maybe I need to add, because I did not say that, so we start for every software build, we start really a new instance, like an EC2 instance, because then we have a fresh environment and it's not polluted, and we ensure the build environment is really, really good.
Yeah, and I think it's also not difficult to imagine. Also planning for future demand of such a platform is quite difficult, not only in terms of virtual CPUs and memory and I/O and storage. So, and this is also now a challenging task BMW got rid of. And yeah, as Thomas already mentioned, initially this platform was built on premises, leveraging multiple data centers within BMW, running on OpenStack. And as you could see, there were some separation in core services like Elastic, Grafana, Prometheus, Artifactory, GitHub, so all the usual software development tools you're probably familiar with. Then there were also some zonal services like BuildBarn and SoulCI, and then of course we have the virtual machines which are executing the real build job. And as you could see can see on the right side, since the start of this platform, the demand was constantly growing. And at some point, BMW outgrew the capacity of 40,000 virtual CPUs. You can see here what they have on premises. And the result of this was that some CI jobs were queued for such quite a time on the CI system until they got executed. And this, of course, means a developer has to wait longer for getting feedback for their code change, which then also decreases his or her efficiency. And in what BMW did in step one, they moved their core services like Artifactory, like GitHub, Elastic, and so on to AWS. And one of the reasons also was that, for example, GitHub Enterprise BMW is using is quite resource demanding. And BMW also couldn't fulfill in a timely manner these specific resource demands to their platform. And it took about 6 months to migrate these services to AWS. And in this time, the demand was still growing and going up.
And if I can add there a small thing, our infrastructure team did a great job. They created a service mesh via this on-prem and AWS cloud, and that helped a lot to migrate step by step these services. So that was, for us, really good. Maybe also an inspiration for such a migration.
Yeah. Yeah, and of course, we have a large AWS Direct Connect in place, which also makes sure that there's a reliable and fast connectivity between on-premise and AWS. Yeah. And then in the second step, BMW migrated project by project to AWS. And this only requires to change a couple endpoints in their system, and then it will magically run in AWS. And this is also how we mitigated risk in such a migration, because if you would have figured out it's not working for their specific project in AWS, it's again just a configuration change to move them back to on-premise and troubleshoot and fix this issue. And as you can see, over the time, on the right side, the demand was continues to grow. So I think last week we hit a new record of running 80,000 virtual CPUs in parallel. And today, round about 2/3 of these build jobs are running in AWS. And because of the importance of this platform, we run it in 3 AWS regions, so in Frankfurt, Dublin, and Stockholm, just to make sure we can provide the capacity BMW needs, but also have a reliable platform if we have some challenges in one of our regions. And the remaining workload you see on-premise, this is just the remaining server capacity BMW has. So these servers didn't reach end of life, and of course, they still use it for their CI jobs. So then let us jump directly in our learnings and what we achieved together to make this working. So I think that's why you are here, and hopefully you will find a couple of these things which you can apply as well. So when we moved this workload to AWS, what we from AWS figured out is that BMW was not leveraging Spot Instance at all. And if you're not familiar, AWS Spot, we provide up to 90% discount, the free capacity we have, and it's optimal for workload which can be interrupted or is fault tolerant and stateless, like CI/CD jobs. So there were a couple EC2 instances which benefit from saving plans, but yeah, BMW was not using Spot at all. And the beauty in using SoulCI, because it's an open source project, is we can change this. And we teamed up, we jointly designed how to add Spot usage to SoulCI. We implemented it together, and a couple weeks later, we pushed a pull request, and then another couple of weeks later, we were able to leverage Spot instance in their CI pipeline. And by today, BMW leverages about 30% of their, or leverage Spot in about 30% of their CI jobs, and achieving a discount between 50 and 70% based on the EC2 instance. But we also believe we can do better. So why only 30%, and why only these non-time critical jobs? And the reason for this is Spot reclaims. So as you may know, if you run a spot instance, there is a 2-minute warning we give you before we may reclaim the instance if we are low on capacity and we need this capacity for a different customer. So this is a trade-off you have to make between using on-demand and spot instances. And BMW and we from AWS, we teamed up again right now, implementing the ability to use the EC2 Fleet API and the capacity optimized allocation strategy. And what does this mean for BMW and what the benefit is? BMW is then able to use the Fleet API even just to start a single instance, but take leverage of the knowledge we as AWS have to start an instance, a spot instance from a pool where we have the largest capacity. And this means we expect, and that's what we have measured in some tests, we will see a reduced likelihood of getting these spot reclaims, and this then hopefully will also enable other workloads to leverage more spot instance, what at the end will also bring down BMW's overall cost for running these CI jobs. As Thomas mentioned, every CI job is executed on a fresh EC2 instance. And this is because to prevent side effects between builds. And if you do this on a fresh instance with a standard Amazon machine image provided by AWS, what every build instance would do first is downloading their thousands of dependencies. So there are some artifacts they are depending on for this software build, which is required locally. There are internal and external Git repositories they have to clone. They may have to install tools or special compilers, and so on and so on. And what we do here is, on a nightly basis, we're running jobs where we pull all these required dependencies into an EBS volume and create an custom Amazon machine image BMW is then using for a build at the next day. And of course, there's not just a single AMI, because BMW builds quite different ECUs on this platform. So there are tens, I believe close to 100 AMIs they are building on a daily basis, and benefiting of having all these dependencies already locally on this instance, and don't waste time in downloading these dependencies and just waiting for minutes until all these dependencies are available locally.
Yeah, and Christian and the team also helped us to improve the upload speed so that we could actually update these images more often, so this cache is actually then hotter and having more cache hits. So that was also really, really good to do that. Another thing about cost optimizations is to choose the right instance type, especially if we use that amount of instances. What we supply to our developers is, and integrators, already a service that if you run one build, you get at the end a reporting of that build, how much the virtual machine had been using during this build. So here we can see it's in tabular form, for example, the memory consumption, and we see that this build always had below 6% of memory. And we transform this also to graphics, so it's easier to read. So this red line is that memory consumption. And that shows, actually, we don't need for this type of build that amount of memory. So in this case, we could reduce the instance type, the memory, and save cost, and not have any impact for this type of build. On the other hand, we see at the right top the CPU utilization, and we see that kind of hits their limit for quite some time. And that means actually that build could benefit from a better machine, maybe a more modern instance type or more cores, and then the build time would be faster. So the developer gets more speed, better experience, faster feedback, maybe even saves a bit cost because we can give that machine back earlier, so compensates also. And this is what we supply. Now, of course, as Christian also mentioned, these builds can be very different depending on what you change in the software stack. So if you do a very low-level change, more gets built. And that is why we actually also supply metrics for the different CI jobs. So we can see the last 24 hours or so, what was their average and max numbers for these consumptions, and that helps them to right-size the ECU types. And here's also links, because there are some actually Linux tools and Prometheus exporter that helps to create that metrics.
And some of you are wondering why don't they use the EC2 compute optimizer. And the reason for this is EC2 cost optimizer needs a couple hours of data before it's able to provide recommendations, what is the right instance type for this particular workload. And that's the reason why we use, or BMW is using Systat and the node exporter to get these data, even the instance is just running for 2, 3, 4, 6 hours, but still be able to do their own right-sizing recommendations.
Yeah.
Okay, I also talked about we are optimizing the base platform, and therefore I would like to shift the focus a little bit now back from the CI jobs to the platform. And I mentioned BMW is using GitHub Enterprise, which is quite resource hungry, I would say. And until March this year, BMW was running an M6A 32x large instance to power their GitHub Enterprise. And what you can see here is the yellow line is the Git push latency they measure on an example project they regularly use just to get observability and all the metric data. The bottom line is the time for a clone operation of the same repository. And if we focus on the yellow graph for a while, so you could see about 680 milliseconds is about the average of pushing changes to this repository, and we see some regular spikes to 1 or 2 seconds. And after moving to an M7A 32x large, so which is the current instance type which is we provide for AMD, we can see now the performance or the average performance increased by 20%, and even the outlier latency increased by almost 50%. So and this is also helping reducing the latency for every developer using these services, but also on the CI tool chain. So if you can clone a repository faster, your build will be also finished earlier. You can return this instance earlier, which also helps reducing your cost. Another example we would like to share is BMW's adoption of Carpenter, an open source Kubernetes cluster autoscaler, where we are the main contributor. So this is a cost graph for one of their EKS, so our Elastic Kubernetes Service clusters in a test environment. And for this particular cluster, BMW spends about $150 per day. And after moving to Carpenter, they could see a drastic reduction in cost. So today they only spend 1/3 on this cluster compared before, when BMW was using the traditional Kubernetes cluster autoscaler. And this was achieved by a much higher resource utilization. You can see here on the top left. So we achieved a resource utilization of almost 94%, and in combination with a much larger spot adoption. So this is, of course, not applicable for every workload, but Carpenter does a really good job in moving also pods from one instance to another instance if we receive an early notification that a specific instance, because it's running on spot, will go away. And also if the demand in your workload changes, or even if just the spot price changes, carpenter may start different instance types which are more cost efficient for you, and then seamlessly work your pods to this new instance.
Yeah, now you have seen some specific improvements we have done together, and now I want to talk about how we also did that together, because that was as important. And one thing was we were able to involve Christian and the team really early, which was, for example, for this migration really excellent, because we also did not know what instance types we need and what is available. And there it's really good to have this discussion early and plan together. Another thing, you have seen the spot improvement. Actually, the spot improvement, we did not anticipate that this is so beneficial, but this was actually because we combined the business unit who knows their jobs with us and with Christian and even with the open source community in the end to get this done. And this was very good. So bringing all parties together is really important. So it's not only we or them or someone else, but bringing that together. And then what we started this year, I think, and also a bit last year already, is that we set really specific goals and targets for what do we want to improve, and then focus on this together. So that was another thing that helped us to get these things.
To be lockstep, yeah.
So?
Yeah, to be just aligned in a lockstep together, yeah.
Yep. And last but not least, we operate this system as a DevOps. So we develop it, we operate it, bring that together, and actually the system is changing all the time. So it's not that we now say we are finished, but we need to constantly see, okay, what are new opportunities, maybe new features in AWS, but also new requirements for us where we need to do something. Yeah, that brings us to also what we did achieve so far. We have seen these changes in our central services like GitHub, and the feedback from our business unit is that the reliability really improved. So we can see this in their feedback. We get that every week actually reported, and that is essential, because if you think about this delivery chain, if you have the instabilities, it really slows down the whole integration. So if one tool has a problem, the whole tool chain has actually a problem. The other thing is, you have seen these charts that we had this tremendous increase. And I mean, we would not have been able to deliver this service anymore if we would have not been able to improve the speed. And that is so I think the last 1.5 years, we improved the throughput of the CI system by 50%, which is really a lot, and AWS was essential there. And third thing is cost. Now here you can see the arrow is to the right, although we have done quite some improvements. The reason is, well, from us, we feel we have just been starting that. So it's a journey we are on. We have increased the transparency of the costs, but we want to drive it much more from this side, and then really kind of align the business with the value, and then optimize speed and quality against this. And I think this fits to AWS, like last year, Werner Vogel's with the frugal architecture yep. Mentioned. I very much like that, so that we drive it from the cost, because actually also it improves the sustainability. So our environment is also very important here. So no surprise. What we want to do next increases FinOps, financial operations. We have started that, and there's actually a talk in the automotive garage starting after our talk about that. That is one thing.
Yeah, and then I also mentioned that criticality of this platform, and just to make sure we provide a platform which is as reliable as possible, we also started a couple of months ago using the fault injection service in AWS just to prove or to prove our beliefs, how the platform will behave if, for example, latency increases. But we also figured out is that some parts of the platform behave differently than we expected. And this was then a great opportunity for us to work on these topics and fix these behaviors before it becomes a problem in production. And with growing maturity or with growing confidence, so we may run these fault injection services or fault experiments in production at some time.
Yeah. The third thing is we can scale containers and we can scale EC2s very easily. What we cannot scale is hardware if you need hardware for testing. So if you have the electronic control units, actually we flash them from the CI system and do validations, but of course this is very costly and very limited. And so we want to move as much as possible to virtual validation and to test that as often and as early as possible. And there's also a talk from a colleague about focusing about this.
And of course, we cannot get on stage these days without talking about GenAI. And I don't want to talk again how GenAI or AI in general can help you to become more efficient in the entire development life cycle. So starting from planning, analysis, and design to implementation, test, and operation. But I would like to show you one or two examples, depending on the remaining time, what we are planning for one of our next hackathons, maybe to inspire you what you could also do with GenAI. And this is a very simplified dependency tree for an artifact. So let's call it A1. And as mentioned before, BMW builds components which has dependencies to thousands or even tens of thousands of these artifacts. And right now, and I believe this is common to most, if not all of you, you have a static assignment of a CI job or CI build to a particular compute requirement. And let's say in this case, we have assigned an M7i 2x large instance to build component A1. So, but in reality, every build is different. So what you could end up with, that all your dependencies are already built and cached. And in this case, maybe just running a C7i instance type would be totally fine, because at the end, you just have to download these dependency, package it, and you are done. But at the other side of the spectrum could be that all of these thousands of artifacts you depend on are outdated and has to be built first before you can build artifact 1. And for such a complex build, maybe an R7i instance type would be the right one. But of course, in reality, for every build, it's something in between. So you don't really know what exactly are the optimal compute requirements for this particular build. So it's almost or always a trade-off you have to do. Provide enough memory so that you can build this artifact and not running out of memory, but also balancing compute. And because we have the data from millions of CI jobs from the past, knowing their exact state, knowing exact, as Thomas saying, their resource utilization, we believe we can use generative AI to predict the optimal instance type for every particular CI build, because we know the dependency tree, we know which artifacts are outdated or must be built, and this is how we even want to reduce cost even further. And then a second example here would be to reduce the speed. So as explained before, you have to build all your required dependencies. And in this example, if we, for example, change artifact A4001, it will also invalidate all the artifacts it depends on. So in this case, it would be A14, A11, and A3. And this, of course, increases the time for for this particular CI build. And what we could do, of course, is we could build all these dependencies we invalidated immediately. But this wouldn't be commercially, or it wouldn't make sense commercially, because you build a lot of software versions you will never use. But based on the data we have, we believe we can predict which version of a particular dependency or artifact will be required in the future, and we can build these artifacts before it's requested. And this, of course, will also shorten the feedback cycle for a particular build, because all these dependencies we may build upfront. So these are just two examples. We brainstormed. We have a lot more of them, but at some point we have to come to an end. But if you have questions, we are happy to answer your questions. Thomas and me will be here around. And yeah, thank you very much for your attention, and have a great rest of the day.